The population of a city obeys uninhibited growth. This is a phrase to indicate that we're going to use the equation A equals A naught e to the kt. A naught is the initial population or amount that we have. T is time, based on whatever the context is here. Looks like we're going with years. Okay, and A is the amount that you have at any specific time. Okay, now, we're told the population was 1,115,000 in the year 2005. Okay, now there's different ways that you can set this up. I'm going to set this up to be t equal 0. That's what always indicates my initial amount. That's why we use a subscript of 0. So t equals 0 is the year 2005. Now, we're told that in 2010 the population was 130,000. Okay, so if 2005 is times 0, 2010 is going to be time t equal 5. Okay, now let's use that information to start with. A naught is the initial amount at time 0, so that's 115,000. Now, I have to find this value of k. I know other information, that the population is 130,000 when my time is 5, by just adjusting from 2005 to 2010. Now I want to use that to find k. So first I'm going to divide by 115,000. I know at least the left side simplifies to be 130 115ths because of my zeros. 1,000 goes into each. Now I'm going to use logarithms. The natural log of 130 115ths equals the natural log of e to the 5k. Because we have base e with a natural log, that right-hand side reduces to just be the exponent 5k from our inverse properties of logs and exponentials. So my k value is the natural log of 130 115ths over 5. Now unfortunately, that's not what the problem's asking us to find. I've just used the information to get to this value of k, and that's going to complete my formula. My question is, what is the population for the year 2020? What does this model predict? Well, let's see. What t value would we need for 2020? It's 10 years later, so this is going to be t equal 15. Okay, now what I'm really going to find then is a equal, I still started with 115,000, e to the, here's my k, natural logs of 130 115ths over 5, all in the exponent, times t, which is 15. Now, you could certainly type this entire thing into the calculator as is. My guess is you're going to want to get an approximation for k. So if we approximate k, natural log of 130 115ths divided by 5, we get that k is approximately 0.0245204644. You don't want to drop decimal places, okay, because that would round before we're ready to round. Alright, so that means for my a value, I can then use 115,000 e to the, this number, times 15. Okay, now, to type that in, 115,000 e to the, I can use the fact that I've already put this into my calculator and do second, the negative sign which says a and s above it. So it'll take my previous answer, and I need to multiply that by 15 within my exponent. And I'm getting an answer of, I'll write down first a decimal, 166,124.76. But now this is a population of people. I want a whole number. Because I don't have a full quantity here, it's okay to say that this would be 166,124, but I would also accept if you do normal rounding and say, well, 0.7 is bigger than 1, so it's going to have to go to 125. Either answer would be fine. You don't have to give both. You have an option on this one. Okay, but the key thing is our formula, A equal A naught e to the kt, which is very same idea as PERT, P-E to the RT, just different variables. A naught is times 0 in the initial population. We used other info that was given to us with a specific time and population to find K, and then we used that to answer the question that was asked.